The escape system has now been armed. The escape tower on the very top of the rocket would fire in the event of any problem during launch. The system designed to pull the spacecraft and the crew well clear of the booster, enabling the Soyuz capsule to then parachute to a safe landing in the event of an emergency during the launch or any of the early stages of the climb to orbit. The Soyuz rocket itself, standing 162 feet tall and weighing in at 680,000 pounds. Again, that Soyuz rocket, 162 feet tall. It consists of the MS-02 spacecraft inside of the protective shroud at the top and the three-stage booster below. The spacecraft was mated to its booster in the three main stages last Friday, and then the entire rocket was transported by rail and erected a short time later to its vertical position. The Soyuz spacecraft, with its three crew members on board, sits high above the three stages of the Soyuz booster, which uses RP-1, basically a refined version of kerosene, and liquid oxygen as the propellant. The first stage of the rocket has 4 liquid engines strapped to the side of the core vehicle. Each of those is going to burn for about 1 minute 58 seconds before they drop away. At that point, the rocket will already be 30 miles high and more than 73 miles downrange, traveling at a velocity of over 3,900 miles per hour. And in this animation, you can see roughly all of the different stages that we'll witness this morning. The Soyuz engines will fire until the thrust is actually enough to overcome those launch gantries holding it in place. And then again, that first stage has those 4 strap-on boosters, which will fire for 1 minute 58 seconds before they detach. The core stage will continue to fire and also serves as the second stage, that core stage firing throughout the entirety of the first. The launch abort system will detach, and then those first stage engines will come off. The core stage will continue to burn until about 4 minutes 57 seconds into flight. The altitude at that point will be 103 miles, downrange over 179, and then the fairings will detach, and then they'll do what's known as a hot staging technique. The second stage will drop away, and the third stage, which has a single engine, will ignite just before that separation, helping to push it away, and then burns until the 8-minute 45-second mark of the flight. At that point, the Soyuz will be in its preliminary orbit of 143 by 118 miles. Then all the pre-programmed controls will go out, the solar arrays and antennas will deploy, and it'll be ready to start its 2-day chase of the International Space Station. But everything's still on track for that on-time liftoff today. Again, launch time is 3:05 a.m. Central, 2:05 p.m. in Baikonur. At the time of today's launch, the space station will be flying at an altitude of about 254 statute miles over the South Atlantic, just to the east of Brazil. Again, this is going to be a 2-day 34-orbit rendezvous, which will culminate with the docking to the International Space Station's Poisk module this Friday on October 21st at 4:59 a.m. Central Time, while the station flies over northern Kazakhstan, just to the southeast of the capital of Astana. And atop the rocket, within the Soyuz MS-02 spacecraft, again, Shane Kimbrough, Sergei Ryzhikov, and Andrei Borisenko, now just about 21.5 minutes from launch. Everything continuing to go smoothly, again, aiming for that 3:05 a.m. Central Time launch this morning. The Soyuz spacecraft itself is split up into different parts. It's 23.5 feet long and weighs in at just 15,496 pounds, and is comprised of 3 different modules, starting off with the descent module, which is situated in the middle of the Soyuz vehicle and contains customized seats for each of the crew members during all of the launch and entry and landing phases, as well as all of the controls and displays necessary for the flight. Also contains the life support systems, the batteries for the re-entry and landing, and the parachutes and soft landing rocket engines used to slow the Soyuz just before touchdown when it lands in Kazakhstan. There's 8 hydrogen peroxide thrusters located on the module that are used to control the spacecraft's orientation or its attitude during the descent until parachute deployment. Also has a guidance, navigation, and control system to maneuver the vehicle during the descent phase of the mission. That module weighs in at 6,393 pounds, a habitable volume of 141 cubic feet, so a bit of a tight squeeze with 3 people. And then approximately 110 pounds of payload can be returned to Earth in this module. And the descent's the only portion that returns to Earth. You move up through the hatch, though, and you enter the orbital module at the top of the vehicle, which is connected via that pressurized hatch. That's where the crew has a small amount of room to move around during the flight to the station. In this case, that 2-day rendezvous has a volume of 230 cubic feet, so a little bit more than the descent module. Has the docking mechanism, the hatch, and the rendezvous antenna located at the very front end. The docking mechanism is used to dock with the space station, and the hatch allows that entry into the orbiting laboratory. The rendezvous antenna are used by the automated docking system, which uses radar to maneuver towards the station for docking. There's also a forward-looking window in the module that they can use to take manual measurements of the distance and closing speed using a laser rangefinder in the event of a failure of that rendezvous system. And then the third and final module is the propulsion module, and that houses the oxygen storage tanks, the main engine and attitude control thrusters, all the avionics and communications and control equipment. The propulsion portion of this module also handles all of the orbital maneuvers, including those needed for the rendezvous with the space station and the deorbit burn at the end of the mission. And then just before they're deployed, the 2 solar arrays are folded up against the body of the propulsion module, which separates from the descent after the deorbit burn, along with the orbital module. And those solar panels have a wingspan of just about 35 feet. The entire spacecraft serving not only as a crew transport vehicle to and from the station, but also an emergency return vehicle in the event of the crew having to leave the station unexpectedly. But for now, continuing to get views of the rocket on pad number 31, everything marching smoothly towards that launch in just about 18 minutes from now at 3:05 a.m. Central Time. The current crew of the International Space Station, hailing from 3 different nations, and is a reflection of the spirit of international cooperation that has really made the most complex spacecraft ever built possible. Truly a 21st century scientific marvel. The international partnership of space agencies from the United States, Russia, Europe, Japan, and Canada have worked together for more than 15 years on the most complex space exploration program ever undertaken. Welcome back with another live view of that Soyuz rocket, just 11.5 minutes away from the launch of Shane Kimbrough, Sergei Ryzhikov, and Andrei Borisenko to the International Space Station. At this point, the leak checks of the crew's launch suits completed, and everything continuing to march along for an on-time liftoff. Today's launch is going to mark the second flight of the new Soyuz modernized systems, or the MS series of vehicles. The first launch was the Soyuz MS-01, carrying Kate Rubins, Anatoly Ivanishin, and Takuya Onishi to the station back on July 7th, and they'll be undocking and landing in that same Soyuz just 11 days from now. Upgrades in the Soyuz MS series from the previous series, which was known as TMA, include more efficient solar panels, also an integrated command and telemetry system for use with the Russian tracking and data relay satellite system, similar to the TETRA satellites that we use on the U.S. segment side for communication with the space station and spacecraft, integrated GPS and GLONASS navigation hardware, allowing all onboard navigation and calculation of these rendezvous burns independent of the ground tracking stations. Also a upgraded Coors NA rendezvous radar, and then an upgrade of the interface between the hand controllers and the vehicle's guidance, navigation, and control system, a redesigned propulsion system, and a new tri-axial angular rate sensor system, and a strap-down inertial navigation system. So a lot of big words, but a lot of important upgrades to this Soyuz spacecraft, and the two-day launch to docking of this second MS series Soyuz will give Russian systems engineers another opportunity to test and validate all of the new systems before the Soyuz program reverts back to that single-day launch and docking to the International Space Station. Already orbiting the Earth, though, Orbital ATK's Cygnus cargo craft is awaiting the arrival of this crew. The vehicle did just launch about 2 days ago on October 17th and is set to arrive at the station on Sunday, October 23rd, packed with over 5,100 pounds of supplies and research equipment. But we're under 9 minutes away now, continuing to get live views inside the cabin. Right now you're looking at Shane Kimbrough. Again, he's in the right seat of the vehicle. The rocket itself still on pad 31. Everything on track for this liftoff at 3:05 a.m. Central Time, 2:05 p.m. in the afternoon in Baikonur. A group of NASA representatives are there in Baikonur, just a short distance away from the launch pad. For an update on activities there, why don't we go now to NASA Public Affairs Officer Rob Navius. And as always, good to hear from Rob and the teams out in Baikonur, ready to watch this rocket climb into the sky just over Kazakhstan. Again, the contingents out there battling some fairly cold temperatures, hovering just above freezing, 33 degrees or so Fahrenheit, and some light snow flurries reported, but nothing that's going to impact the on-time launch of this Soyuz vehicle today. Right now, we are just 6 minutes and counting away from this liftoff. And so at this point, the Soyuz first and second stage engines are ready for launch, and telemetry has been received from the rocket indicating all the primary and backup systems are ready for launch. And we'll stand by now as we should start getting some performance calls coming in. And you'll hear performance calls from Russian engineers throughout the flight into orbit, which again takes about 8 minutes and 45 seconds from liftoff until the Soyuz is in its preliminary orbit. First-time flyer Sergei Ryzhikov in the center seat, the Soyuz commander today. To his left, Andrei Borisenko, a veteran cosmonaut with one long-duration mission already on board the station. And then in the right seat, NASA astronaut Shane Kimbrough, making his second flight into space, his first on board a Soyuz, and his first time as a long-duration crew member on board the station. 5 minutes and counting away from launch. We should shortly hear about the launch key being inserted in the launch bunker, and they do use an actual physical key, and that transitions the launch sequence into its automatic mode. For under 4 minutes, 30 seconds away now. Launch control reporting the range is clear at Baikonur. The Soyuz ready to begin its journey.
Run 1 command. Combustion chamber nitrogen purge.
Under 4 minutes away now from launch. Onboard systems switching over to onboard control, and the commander's cockpit displays and their controls getting activated. The crew members already have their helmets closed on the oxygen inside of their suits. Again, they're going to wear these SOCO launch and entry suits throughout all of the ascent activities today. They'll get a chance to get out of them during that 2-day rendezvous with the station.
Onboard measurement system is activated by Run 2 command.
Getting the confirmation, onboard systems activated. 3 minutes, 15 seconds away from launch.
Oxidize and fuel. The draining of
And we'll
oxidizer.
also hear those calls that fuel lines and various other elements of the rocket being purged with nitrogen, that being done to help fireproof them, removing any excess vapors of fuel and oxidizer from the lines before the actual liftoff. Right now, 2 minutes, 45 seconds away from launch.
Booster propellant tank pressurization initiated.
And so the booster tank pressurized for flight. This done to help optimize the flow of the fuel and helps add to some structural support to the rocket. And we are now 2 minutes and counting to launch. Coming up on 1 minute, 30 seconds. Soon we'll look to hear that the ground propellant feed to the rocket has been terminated. And then the milestones will start picking up very quickly now. We're under 1 minute and 30 seconds. And we are now just 1 minute away from liftoff.
1 minute to liftoff. Vehicle to internal power.
So the first umbilical tower separating, the second will separate just 15 seconds before launch. We heard the ground propellant feed's been terminated. The Soyuz now on internal power, just about 20 seconds away from launch.
Launch command issued for ignition. Second umbilical tower separates.
The second umbilical tower has retracted. You can see the engines firing now, going up to flight speed and liftoff. Shane Kimbrough, Sergei Ryzhikov, and Andrei Borisenko blasting off from Kazakhstan, making their way towards the International Space Station.
"15 seconds.
Getting good calls from the teams out in Baikonur, everything looking nominal or normal throughout the flight so far. The first stage of the Soyuz delivering 930,000 pounds of thrust from those 4 strap-on boosters and single-core engine.
First